Okay, so this is Chapter 6, Lesson 4, and today we're going to talk about Hess's Law. So it's inefficient to use calorimetric calculations to determine the enthalpy for every possible reaction. Instead, we take advantage of enthalpy being a state function and using pre-existing databases to calculate the enthalpy for a reaction that we haven't necessarily carried out. So it's kind of like someone else has done the work for us, and then we're going to reap the rewards. So delta H is an independent pathway. So whether a reaction takes place in 2 steps or 5 steps, the net delta H will be the same. Remember, because it is independent of the pathway, it makes it a state function. The magnitude of delta H only depends on the amount of material undergoing a change and the initial and final states. So Hess's law states if a reaction is carried out in a series of steps, delta H for the reaction will equal to the sum of the delta H's for all the individual steps. So basically the sum of the parts equals the sum of the whole. So for the reaction of the combustion of methane here, forming carbon dioxide and water, actually, whenever we've looked at this in the past, we just look at the reaction and assume that it happens. But there's actually 2 smaller reactions that take place. So our job when we look at these reactions is we need them to equal the final reaction, which is this one up here. So in order to do that, we can either double a reaction, and if we do, we have to double the delta H. We can reverse a reaction, and if we do, we need to reverse the sign. We can have a reaction, in which case we would have to have the delta H. And then the sum of those should equal the whole reaction. So let me show you how this works. When we look at this, 2 steps, we can see that the 2 waters here cancel with the 2 waters here. Okay? And then nothing else will cancel. So what's left is CH4 plus O2 yielding 2H2O and CO2, which matches up with our final equation. So in this case, we're going to sum our delta H's. Negative 802 plus a negative 88 yields a negative 890. So in this reaction, we're just going to simply use letters as variables to see what's going on in a reaction. So A plus B yields C. And we have 3 subsequent reactions. A plus B yields D, D yields E, and E yields C. So let's see what's going on in this reaction. My E is going to cancel with my E. And my D is going to be canceling with my D. So I'm left with A plus B yields C. So in this case, I would just add delta H1, delta H2, and delta H3. All right, let's look at the Haber process for the formation of ammonia to see what's going on here. Now here they gave us a little spin. They gave us the final reaction, and they gave us the energy for the final reaction. They gave us the delta H's for step 2, but not step 1. So if I were to write a general equation for what is going on in this equation, it would be delta H net, which would be my total, equals delta H of reaction 1 plus delta H of reaction 2. So what do we know? We know that delta H net is negative 92. We don't know this, but we do know that reaction 2 is negative 187.6. Now let's see if anything has to be changed. H2 is going to cancel with nothing here. Hold on a minute. I did that wrong. Let me erase this. Okay, so I have 2H2 and 1H2 gives me 3H2. My N2 is here. Okay, my N2H4s cancel and my 2NH3s. So I don't have to change any of my signs. So basically, when I solve for x, right, when I solve for x in this reaction, I'm going to get x equal to 95.4 kilojoules. So in this reaction, they didn't ask us for the total, they asked us for one of the individual steps. Okay, so we're going to step up our game a little bit on this one, and we're going to have to manipulate this. What is the enthalpy of combustion of carbon going to carbon monoxide? Carbon going to carbon monoxide. So the first thing that I can see right now is if we're forming carbon monoxide, that I need to flip this equation. So I'm going to rewrite this as CO2 yields CO plus 0.502. And if I flip the equation, I have to flip the sign. So my delta H is going to be equal to 283 kilojoules. So now, let's see what I have going on. My carbon dioxide is going to cancel with my carbon dioxide, and I'm going to have a half of O2 here, leave this with a half O2. So I'm going to be left with carbon solid plus 0.5 O2 gas yields CO. And when I do the math on this, it's going to be negative. So we've got negative 393. So delta H is equal to negative 393 plus 283. I didn't have to put that in parentheses because I forgot to change the sign. And that's going to give me negative 110. Oh, this is 393.5. Okay. Negative 393.5 plus 283 is negative 110.5 kilojoules. And that's my delta H for the reaction. Okay, now we're really going to turn it up a notch. Water gas is a very important mixture of carbon monoxide and hydrogen gas prepared by passing steam over hot charcoal at 1,000 degrees. Calculate the delta H for the water gas reaction. Okay. So, up top is your water gas reaction. This is what you want to be left with. So now I'm inspecting. My carbon's on the left in reaction 2, so I'm going to leave that there. I need water on the left, so right away I can see that in this reaction I need to reverse it, and I also see that I only need one water, and there's no water in any of the other subsequent reactions, so I also have to half this and reverse it. So I'm going to do 1/2 and reverse. So I'm going to rewrite this one down here. I'm going to rewrite it as H2O yields H2 plus O2. There's my half, and I need to change the sign. So my delta H is now equal to 483.6. Okay, and in my last reaction, I also see that I need CO on the right in equation 1 here. So I have to reverse this reaction, and I'm also going to have that. So I'm going to do 1/2 and reverse. So I'm going to rewrite this one. So I'm going to have CO2 yields CO plus 1/2 O2. Oh, I forgot to have my my joules here. Sorry about that. So this is going to give me, half of that's going to be 241.8, and then this is going to be positive delta H here. We have to switch the sign, and that's going to be 283. So let's see what's going on now. I'm going to cancel everything out. So, I cancel my CO2, and I cancel O2, and what else do I have? Let's see, I've got carbon, I have water, I have CO2, CO, I have H2, what's going on with my O2? Oh, because geez, this should have been 1/2 O2, because half of O2 is 1/2 O2. So then a half of O2 and a half of O2 cancels with O2. All right. You got to look at these with a fine-tooth comb. So now I have my final reaction of C plus H2O yields CO and H2. So now I'm going to take my negative 393, my positive 241.8, and my positive 283. And I get a delta H equal to 131.3 kilojoules. Okay, in this problem they want us to calculate the delta H for the reaction of fluorine gas plus water to produce hydrogen fluoride and oxygen gas. So the first thing that we notice when we look at the subsequent reactions is that we need 2 fluorines, and this first reaction only has 1, and there's no other fluorines anywhere. So this one's got to be doubled. And the other thing that I notice is oxygen has to be a product. Oxygen gas has to be a product here. And here it's a reactant, so we're going to have to reverse this reaction. So the first thing that I will want to do is double the first one. So 2H2 plus 2F2 yields 4HF. Okay, and in the second reaction, if I reverse it, I'm going to get 2H2O yields 2H2 plus O2. Now let's see what cancels. My 2H2s cancel, and that should be it. So I'd be left with 2H2O and 2F2 yields 4HF and O2, which is what I have in my original reaction. So I have to double this. This was 1074, and I have to reverse this. So this is positive 572, which means that I get a net of negative 502 kilojoules as my delta H. All right, let's look at this bottom reaction here. We have carbon occurs in 2 forms, graphite and diamond. The enthalpy of combustion of graphite is negative 393.5. So that means when I have graphite, which is carbon, combustion plus oxygen, and that's yielding CO2, that is a delta H of negative 393.5. Okay? And that of diamond, so the combustion of diamond is negative 395.4. Okay. But they're looking for an overall reaction of graphite to diamond. So diamond has to be on the right. So we would have to reverse this reaction. So I'm not going to rewrite the reaction because it's just going to be carbon dioxide yields. Well, all right, I'll rewrite it. I'll rewrite it up here. CO2 yields diamond plus O2. So what's going to happen now is my O2 is going to cancel with my O2, and my CO2 is going to cancel, and I'm going to be left with graphite going to diamond. So I reversed this, so I need to reverse the sign on this. So negative 393.5 and a positive 395.4 is going to give me a net of positive 1.9 kilojoules, which is what I was supposed to get. Okay, in this last one, they want you to calculate the delta H for the reaction of nitrogen monoxide and an oxygen to form nitrogen dioxide. So you're given 3 subsequent reactions. In the first one, in reaction 1, you can see that NO2 is on the right, so we're not going to do anything with that. In the second reaction, I've got oxygen O3 on the left and 3/2 O2 on the right, and there's no O2 in the equation. So what that tells me is that I have to reverse this equation. So I'm going to put 3/2 O2 going to O3. So that means I'm going to change the sign on this to positive 142.3. In the last reaction, I am going to have this, and I'm going to reverse it. So 1/2 and reverse. So 2O becomes just O going to O2. That's a half of O2. So let's just make sure this is going to work first. So I definitely have an NO, and I definitely have an NO2. So let's see what else we can do. O3 is going to cancel with O3, and O2 and a half of O2 makes 3/2 O2, which is going to cancel with 3/2 O2. So then the only thing I'm left with is down here. So that's NO plus O yields NO2. So I did good there. So we reversed that. On this last one, we have to have it, and we have to reverse the sign. So half of 495, just lost my spot, is negative 247.5, and this was still negative 198.9. And that's going to give me negative 304.1 kilojoules, which was what I should have gotten. Okay, so that's going to be it on this, and I'm not going to do a problem set with this video. I'm going to wait till I just do the last section, the enthalpy of formation, and then there'll be a problem set.